Hey everyone, welcome back to my channel, The Beaker and the Board. So in my previous video, I have told you, I have explained to you, I have taught you how to calculate the oxidation states of various elements. Please do not proceed to this video unless and until you are well aware of that. Go through my previous videos, understand the concepts and then come back to this. In my today's class, I am teaching you how to balance redox reaction by ion-electron method. Now, before knowing about this particular topic, you need to know that why is it so important? Because in your junior classes, you have balanced reaction by simply hit and trial method. Simply you have given numbers at random and then you have balanced. That was quite uncertain and a time-taking process. But this process is very convenient, very useful and proceeds through some rules. Now, what is the significance of this? When you learn ion-electron method, you understand. It shows you that the exact number of electrons transferred. That means how many electrons are lost during oxidation and how many are gained during reduction. The next one is this method not only obeys the law of conservation of mass, but also obeys the law of conservation of charge. What is law of conservation of charge? I will tell you this in this video again, I will repeat it. Now let me just simplify it. Law of conservation of charge means the number of electrons lost is equal to the number of electrons gained. If 6 electrons are lost during oxidation, all the 6 electrons must be gained during reduction. This is what law of conservation of charge states. Now, let's take an example. Say for example, we are discussing about dichromate ion. Reaction of dichromate ion Cr2O7 2- dichromate ion with Fe2 plus ferrous producing chromium plus 3 and Fe3 plus, that is ferric ion. So when you are given this kind of reactions, what do you need to do? As I said, ion-electron method follows some rules. The first rule is to find out the oxidation state of every atom involved in the reaction. We are having 3 atoms here, chromium, iron and oxygen. You need to find out the oxidation state of every element involved. So in dichromate ion, chromium is having an oxidation state of +6 and oxygen is having -2 oxidation state. Fe2 plus being a monoatomic ion, the oxidation state is equal to the valency. That means the oxidation state is +2. Chromium +3, oxidation state is +3 and iron is plus, and ferric Fe3 plus oxidation state is +3. So the first step is to calculate the oxidation state of every element. You may say, ma'am, on the left hand side, you have written 7 oxygen. Where are the oxygen atoms on the right hand side? Because atoms should be equal. All the atoms must be present. Where are the oxygen atoms on the right hand side? As you proceed with the balancing, you will see that the oxygen atoms will also be balanced. So after the calculation of oxidation state, we need to identify which one is undergoing oxidation and which one is undergoing reduction. Now see, here chromium, I have written the reaction again. Cr2O7 in dichromate, chromium is in +6 state. You need to calculate. I have taught you already. Understand and calculate that. Okay. So chromium is in +6 oxidation state, which is changing to chromium +3. That means there is a decrease in positive charge. Whenever positive charge decreases, that is called reduction. And Fe+2 ferrous is changing to Fe+3 ferric, which is increase in oxidation state, or increase in positive charge. Increase in positive charge, which is called oxidation. So after the calculation of oxidation states, we have understood which species is undergoing oxidation and which one is undergoing reduction. The third step involves writing the oxidation half reaction and reduction half reaction. We will separate the two half reactions. The first step is, let us write oxidation half reaction first. In the oxidation half reaction, what can we see? Ferrous ion Fe plus 2 is changing to Fe plus 3. Fe plus 3. There is an increase in positive charge. And how much is it increasing? Only by 1 unit. Plus 2 is changing to plus 3. That means there is only 1 unit change. So Fe plus 3 plus 1 electron. This is the oxidation reaction. Let me mark it as equation 1. Now, the next one is writing the reduction half reaction. Reduction half reaction. What can you see in the reduction half reaction? It is chromate, dichromate, Cr2O7, 2 minus dichromate plus Fe2 plus. Dichromate ion changing to chromium plus 3. Chromium plus 3. Now see, the first one is, here chromium is in plus 6 state, changing to plus 3. The first thing is, how many unit is it changing? 3 unit. But see one thing, on the left hand side, we are having 2 chromium atoms. On the left hand side, we are having 2 chromium. But on the right hand side, we are having only 1 chromium atom. So first of all, let us balance chromium. Take 2 Cr plus 3. Now see, chromium on the left hand side and chromium on the right hand side are equal. Now see, plus 6 to plus 3. Plus 6 is changing to plus 3. How much is the change? 3 unit change. 3 unit change for 1 chromium. 3 unit change for 1 chromium. For 1 chromium atom. Since there are 2 chromium atom involved, for 1 chromium it is plus 6 to plus 3. Since there are 2 chromium atoms, that means the total is total unit change. Total change for 2 chromium atoms. For 2 chromium atoms, it is 3 into 2, that means 6 units change. In Cr2O7, in dichromate ion, each chromium is having plus 6 charge. Each chromium, it's not for 1 chromium. Each chromium having plus 6 oxidation state. Now, that is changing to plus 3. So, per chromium, 3 unit change. So, for 2 chromium, it is 6 units change. So, that is plus 6 electrons on the right hand side, on the left hand side. So, let us take this. No, not now. Let's move to the next part. So, the reduction reaction stands out to be something like Cr2O7 2 minus plus 6 electrons gives 2 chromium plus 3. Now, I hope you can understand that all the atoms are balanced except oxygen. So, whenever you start balancing redox reactions, you need to keep in mind that balance all the atoms except oxygen and hydrogen. Balance all atoms except oxygen and hydrogen. See here, in our equation 1, iron is 1, 1 on both the sides. In reduction half reaction, 2 chromium on the left hand side. Similarly, 2 chromium on the right hand side as well. Now we are having 2 chromium atoms on the right hand side as well. The next target is to balance oxygen atom. So what do you need to do? The fourth step involves balancing of oxygen atoms. What will you do for that? To balance oxygen atoms, this is a very important and mandatory step. To balance oxygen atoms, add water molecules. Add water molecules to the side deficient in oxygen atoms. To the side deficient in oxygen atoms. And the number of water molecules to be added, the number of water molecules to be added is equal to the number of deficiencies. Like for example, in this reaction, what can you see? Here we are having Cr2O7 2 minus plus 6 electrons. On the right hand side we are having chromium plus 3. See, on the left hand side we are having 7 oxygen atoms. On the right hand side there are no oxygen atoms at all. That means the right hand side is deficient. Deficient of what? Deficient of oxygen atoms. The right hand side is deficient of oxygen atoms. I hope it is clear. On the left hand side we are having 7 oxygen. On the right hand side there are no oxygen atoms, 0 oxygen atom. And what is the deficiency? How much is the deficiency? The deficiency is 7. 7 on the left hand side minus 0 on the right hand side. So 7 minus 0, 7. So what will you do? You will add 7 water molecules. What will you do? The next step is something like this. See, Cr2O7 2 minus plus 6 electrons. Add water molecules. How many water molecules? Number of deficiencies. 7 deficiencies are there. So add 7 water molecules on the right hand side. Number of oxygen atoms deficiency is equal to the number of water molecules to be added. And which side will you add? The side which is deficient of oxygen atoms. Suppose, for example, if the left hand side would have had 7 oxygen atoms and the right hand side would have had 4 oxygen atoms, then which side would have been the deficient one? The right hand side, right? Suppose a reaction would have been given to us where the left hand side is having 7 oxygen and the right hand side is having 4 oxygen. So which side is deficient? Right hand side is deficient, right? Right hand side is having less oxygen, is deficient. How much is the deficiency? 3 oxygen atom deficiency. 3 oxygen deficiency. So what would have you done? You would have added 3 water molecules on the right hand side. Add 3H2O. Which side? On the right hand side. Add 3H2O on the right hand side. This is fundamental thing. Whichever side is having less oxygen, that side water molecule has to be added. And how many will you add? The number of water molecules will be equal to the number of deficiency. How much less is it having? If it is having 3 less oxygen atom, then add 3 water. Now the next question is, now ma'am, oxygen is balanced. 7 oxygen on the left hand side, 7 on the right hand side as well. But now hydrogen comes in. What to do for that? The next step, the 5th step, involves balancing hydrogen atom. To balance hydrogen atom, what will you do? To balance hydrogen atoms, add equal number of H plus H plus on the opposite side, to which H2O is added. H2O is added. That means in this reaction, you have added 7 water molecules on the right hand side. So what will you do? You will add 14H plus, because 7 into 2, 14 hydrogen. So you will add 14 hydrogen, Cr2O7, 2 minus, plus 6 electrons. You have added water on the right hand side. Now you will add H plus on the left hand side, always on the opposite side, plus 14H plus on the left hand side. Then the reaction stands out to be something like this. See, now all the atoms are balanced. Chromium 2 chromium on both the sides, 2 chromium on both the sides, 7 oxygen atoms on both the sides, 14 hydrogen on both the sides. Let us mark this as equation 2. What was our equation 1? The equation 1 was something like this. The equation 1 was something like this. Now see, the problem is, as I said, the law of conservation of charge. What did I say? The number of electrons lost in oxidation. How many are lost in this? In this oxidation reaction, oxidation half reaction. How many electrons are lost? 1 electron is lost. Whereas in the reduction reaction, in the reduction half reaction, how many electrons are gained? 6 electrons are gained. 6 electrons are gained. That means definitely the number of electrons are not same. If 1 electron is lost, then how is it possible that 6 electrons are gained? So what to do? We need to take the LCM. Take the LCM, the last step for balancing the charge. Balance the electrons. Balance the electrons. What do you need to do? Take LCM of each electrons. Here 1 and there 6. 1 and 6. That is 6. LCM of 1 and 6 is 6. So what will you do? Multiply equation 1. Multiply equation 1 into 6. Equation 1 will be multiplied by 6 and equation 2 will be multiplied by 1. Equation 2 will be multiplied by 1. So what is the next step? The next step is write down the reactions. It is 6 Fe2 plus gives 6 Fe3 plus 6 electrons. Remember, not only the electrons, the whole equation has to be multiplied. So what happens? The next thing is, that means each Fe2 plus is, if each Fe2 plus is releasing 1 electron, each Fe2 plus is releasing 1 electron to form 1 Fe3 plus. This is the thing. If 6 Fe2 plus is taking 6, if each Fe2 plus is accepting 1 electron, is losing 1 electron and forming Fe3 plus, that means 6 Fe2 plus is losing 6 electrons to form 6 Fe3 plus. And the next one is Cr2O7, just as we have written before. Cr2O7 2 minus plus 6 electrons plus 14H plus. Arrow. What happens in the product side? On the product side we are getting 2Cr plus 3 plus 7H2O plus 7H2. Now add up these two equations. When you add these two equations, what happens? See, 6 electrons get cancelled. So the overall equation stands to be 6Fe plus 2 plus Cr2O7 2 minus, that is dichromate ion, plus 14H plus arrow 6Fe plus 3 plus 2 chromium plus 3 plus 7H2. That means my overall equation stands out to be something like this. I will take many more classes where I will teach you more balancings. This is just one example. I will come up with many more. Please go through this example, understand the steps, practice by yourself. If you have any doubt, comment down. I will solve your doubt in my next video. And in this video, I am providing you a homework. I am giving you a homework. The question is, what is the role of dichromate ion? What is the role of dichromate ion? Cr2O7 2 minus. What is it known as? It is called dichromate ion. What is the role of dichromate ion in this reaction? Please comment down whatever your answer is. Let me check whatever you have understood. Please consult my previous videos. I will give you the link with this so that every concept regarding oxidation, reduction, calculation of oxidation states, and the rules for the calculation of oxidation state is clear to you. To understand the balancing, your previous concepts should be very well into your head. Okay, thank you everyone. Follow for more videos.